Alright, hello my wonderful students. This is Simplifying Radicals. So today we're going to be talking about how to get everything out of this square root symbol, which is technically a radical. So before I want to kind of explain to you that this here, maybe not at this point, but this is going to be the same thing as if we put it in parentheses and we call it 64v to the fourth power to the 1/2. Because even though we don't know this is called a square root. There's an invisible 2 here that we don't usually put because it's like the standard of it. So in order to do that, we have to figure out everything inside here. So let me erase this so we can see what we're actually doing now. Or I'll do the work in blue. So what we're going to do is we're going to break down everything into its primes to make it easiest. So prime is basically any number that multiplies by itself. And 1, and nothing else like that. For example, like 3 times 1 would be 3. 3 is a prime number because no other number besides 3 times 1 is prime. Can multiply to be 3. But, for example, another number bigger than that would be 4. 4 can be multiplied by 1 times 4 and 2 times 2. Since there's 2 different ways to get to there, or like more than one way to get to 4, it is no longer a prime number. Okay, so we're basically just going to split off each of these. So I know that 64 is 8 times 8. And normally I would go ahead and just keep it like that. But I'm not going to do that this time because, this would make 8 squared, which you can take out. But since we're breaking everything into primes, I want to make sure we understand this. This is also 2 times 4. This is also 4 times 2. And this is 2 times 2. And then 2 times 2. And then here we can notice we have 1, 2, 3, 4, 5, 6. 6 2's all together. So we'd have the square root still. And now we're going to put 6 2's. 2 times 2 times 2 times 2 times 2 times 2 times 2. And there is 6 of them because there's 6 of them here. 1, 2, 3, 4, 5, 6. And we have v to the fourth power. I know that v kind of looks kind of bad, sorry, but that's a v to the fourth power. I guess it could be u. But we're going to add those 4 v's as well. 1, 2, 3, 4. And now we're going to go back to what I talked about there being an invisible 2 here. So what we're going to do is we're going to group these up in pairs. 2, 2, 2, 2, and 2. Okay, so what that's going to do is now if we take it out, well, in order to take it out, I should say, we're going to have our square root, and we're going to combine them now. So we're going to have this pair would come down as 2 squared times, this pair would come down as 2 squared, this pair would come down as 2 squared, still multiplying them, this pair would come out as v squared, and this pair will come out also as v squared. So now we have, with our imaginary 2 here, now we have something we can actually cross out. So we have, this would come out with this, 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 and this. So this would actually equal all the numbers that are left over. So we have our 2 times that was this one, times our 2, which is this one, times our 2, which is this one, times our v, which is that one, and times our v. And this would end up being 2 times 2 would be 4. 4 times 2 would be 8. And v times v would give us v squared. So this would be our solution to the radical. Just like we said here, since we had 2 here, we could technically stop and make that 8 squared. And then this would cross out here with this, and then it would still give us 8. But I want to break it down into primes right now to make it easier to see future ones.